Hello, I'm Nick Grace from the Royal College of Art. I run the 3D printing department, and we make prototypes for our students. We're part of the whole making environment of the college, which includes subtractive processes, CNC, laser cutting, and also we're moving into robotics, manual handling, and the software control of all of these processes, as well as, of course, the traditional workshops. So just to start with 3D printing, or additive layer manufacturing, when we talk about 3D printing, a lot of people think of a little brass nozzle which squirts out some hot, smelly plastic, and it makes an object that isn't quite matching up to our expectations of what we thought we were going to get. And it's made by a machine which is constantly going wrong. It needs constant attention, tinkering with. And people get fed up with it. And that's a shame, because there are proper ways, much better ways, of making objects digitally from 3D CAD. This object we made for the Science Museum, it's a full-scale human brain using a process called SLA, which was developed in 1986. And our particular machine was made in about 98, I think. So it's nearly 20 years old. It's still running the original software. We haven't updated it for 10 years. And the operating system, although the computer has had bits, drives replaced, power units replaced, and the lasers have been recharged, the computer itself is still running the operating system that it was made with, Windows NT, for those of you who can remember that far back. So this is quite an interesting point. If we design really carefully, really well, and we engineer for the future, then we can have machines that run for a very long time. But how appropriate is that when we have tools like this at our disposal? This is the top one is a 3D scanner, and the bottom one is called a haptic arm. It's basically a digital sculpting tool. And for example, one of our jewelry students may come to us and use these two bits of kit, and it's quite possible that they don't know how to draw with a pencil, they don't know how to do beautiful renderings with a paintbrush, they don't know how to file a piece of metal, or they've never filed a piece of metal in their lives, and they certainly don't know how to solder two bits together. And yet, using those two pieces of kit, they can produce a beautiful piece of jewelry, they can make fantastic renderings on their computer software, and then they can give us the file, and we print it on our high-resolution wax printer, and it makes the master for a lost wax casting process, which is done by a bureau. It's then polished professionally and given back to the designer as a finished object, ready for sale on their website. That opens up a whole raft of questions about skills gaps, new skills, and I'm not going to go to any of it now, and I'm not going to come down on one side or another, but it does mirror what was said earlier on by some of our speakers. This project, on the other hand, is a folding wheel by Duncan Fitzsimmons, who is one of our engineering design students in a partner master's course with Imperial College. And it was printed on a polyjet printer, which uses support to separate the parts of a mechanism. So you design your working mechanical part, moving part, in CAD, and the support material stops the moving parts from sticking together. So you could have half a dozen iterations of that design, print them off in maybe half an hour, and decide which one is the best. And they come out as a working model. But interestingly, Duncan didn't use us exclusively. That's a sample of the prototypes that were made for this folding wheel, which initially was for a bicycle, is now marketed as the Morph wheel by a New Jersey company in the States. And you can see that the prototypes used there were using 19th century traditional techniques on 20th century equipment. So it's the balance and the mixture of technologies and skills that's important. And equally, you could have designed your CAD program to run virtual iterations of your mechanical part to find out whether it works or not. These objects are art pieces, really. The main one is by Peter Coffin, a New York artist. And we built it for an exhibition in the Barbican. It's a human skull, CAT scan, and it's been turned inside out. If, in effect, it's been scaled about its center, about its origin, with a value of -1. So all the external features of the skull are now on the inside, and the brain case, lumps and bumps, are on the outside. So with software, you can do things that you wouldn't do normally. And in the back, we've got 2 examples from a display by Barbara Rauch, who's a German artist. It's really a project about perception, recognition, and identity. And she's showing the morph from a male human skull to a wolf in gradual stages. And it's not only the physical shape that's morphing, but it's the color as well. And all of these things you can do in software, and then you can get a machine to replicate it for you. You don't have to get your hands dirty in the workshop to do that. And it opens up a discussion on what can software do in the design process. Could we, for example, go home one evening and set the machine to run through a whole series of different iterations say it was making this titanium mask. This was another object in the Science Museum. And if you look along the bridge of the nose, we were really taken by the gritty texture. It's titanium powder that is melted using an electron beam, not a laser, it's an electron beam, so it's a much more intense process in a vacuum. And it's produced that sort of figure of 8 on the bridge of the nose. And that's an artifact of the fact that in order to get the piece to fit in, it had to be tilted back and the nose was horizontal. There's nothing I can do about that. I can't tilt it because it doesn't fit in the box, and I can't adjust the way the machine decides how to draw. That's literally, you can see the path traced by the electron beam as it goes over the metal powder and melts it. That's set in the factory. I can't adjust it. But supposing I could teach the computer that, just like a puppy, this is good and this is bad, don't do that. And it would then, you go home and leave it to sort this out, and it runs through virtual iterations of it. And after it's done, say by midnight, it's done several thousand, and it picks out the half dozen best ones, and then it starts a 3D print. And by the morning, you've got half a dozen samples of what the computer thinks is right. And then you tell it which is the best one, and it learns what you like. Just like a puppy, it learns how to please its master. We've got, in the news at the moment, we've got AI systems playing games. It's the next sort of big step in artificial intelligence. I think not just the tools. We can get excited about all these toys that come along, but I think the software-driven decision-making equipment is going to change the design, the way we design, much more than the tools themselves. So, on the one hand, you're going to be able to do fantastic things. On the other hand, you are going to hand over control to an algorithm. And if you're a designer, that's a choice that you hopefully will be able to hang on to. If you don't, someone else will make it for you, and they'll say, we're going to do it this way, and you'll say, well, no, this is the better way. And they'll say, no, 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 this is cheaper, we're doing it this way. So as designers, we have to absolutely keep on top of what the tools are, what they're doing, and perhaps more importantly, as we get further into the 21st century, what the tools are thinking, what decisions are being made on our behalf. So a little bit scary, perhaps? Perhaps not. That's it from me. Thank you very much.
Thanks, Nick. I'm thinking back to when I was at school. I'm sure there was one of those resin, 3D resin model making, and it is a fascinating. I suppose when you're faced with that now, I suppose you are faced with the fact that it's driven by very old software, and no one knows how it works. I mean, but you are still using that kind of technology.
We are, yes, and it's very dumb technology. They're not 3D machines at all. They can do a 2D flat print, and then when they've finished it, there's an instruction to move the bed down and then do the next layer. So the machines don't know anything about the surface finish or the shape.
But I suppose the reality now is that with the power of computing, but also the power of cloud networks and being able to hook up to multiple server farms to actually get your computing done, that must make optioneering, conceptioneering, whatever you like to call it, much more the order of the day.
Yes, and one of the powers of cloud computing and cloud designing is that you can have a designer who doesn't know the market very well, will put out an iteration, and then all over the world different people say, well, over here we want this, and over there we want that, and they can all work together and hopefully come up with the right solution.
What are you seeing for your students? Are you seeing the next generation of students really embracing this as a technology, or are they embracing it as a design tool? Are they in love with the technology, or are they in love with what it enables them to do as designers?
I think what we try and encourage them to do is to embrace it as a way of thinking, as a way of approaching the world. And then from that, once you've decided that the way to approach it is just to keep asking questions, then you don't have to slot yourself into one or the other.
So the final thing on that, I mean, how long before we start printing houses?
Well, we are printing houses at the moment, but very, very slowly. And to me, the future of construction is not having a huge gantry crane that spits out concrete. I don't see that happening. What I do see is closed factories, black factories, if you know what I mean, dark factories, where everything's done automatically using the full range of 21st century technology, and then driverless trucks and driverless cranes will transport the materials to site and assemble them automatically.
Now, it is an interesting concept for the future with DFMA or off-site fabrication, and certainly being able to print components to order is certainly a very exciting prospect. Yeah.
Definitely. Custom printing and user-centered design algorithms and softwares, I think, they'll make a big difference.
Nick, thank you very much for sharing what you're up to at the Royal College of Art. Nick, Grace, round of applause. Thank you very much.
Thank you.
Thanks, Nick.